you have two different goals in mind. You got your AMPA receptor, NMDA receptor, and now we've got our dopamine receptor as well. We've got our dopamine neuron. We've got our parallel loops for the various goals. Both of these ideas came to mind. Watch the video is the one. Let's suppose that one out, and that's the one I'm doing. Now, what you can see here is that I've got a dopamine release, if the video is rewarding. Well, that shouldn't be a surprise to you. In this case, which synapse strengthens? Well, let's see. If I'm watching the video and I'm getting dopamine, I guess it will be this one. If I'm watching the video, there's something you should be seeing here that you're not seeing, a certain neurochemical that you should be seeing. Just chat it in if you have the idea. Yeah, you should be seeing glutamate, right? And in fact, should you be seeing glutamate released here? No. You should be seeing glutamate released here. That's how you know I'm watching the video. If I'm watching the video, I'm not cooking lasagna, I'm not even considering cooking lasagna, I'm getting glutamate release here as I'm watching the video. I'm watching the video, and it's not like dopamine is only released onto this neuron. Dopamine, remember, it's in the midbrain. Dopamine's being released throughout the entire striatum, and you're getting this sort of a flood of dopamine throughout the entire area. And yet, if I'm watching the video, that's the one that's going to get strengthened. So we're going to think about that for a second. In the striatum, that's true as well. You need calcium to flow through the NMDA receptor, same deal. But in this case, it's not enough just to have the AMPA depolarizing the cell, but you also need dopamine. If you've got glutamate binding to the AMPA so that the NMDA can be online, and you've got it binding to the NMDA, so you've got, that's set up perfectly. And since I'm enjoying the video, I've got some dopamine binding to a dopamine receptor. Now you've got the magic ingredients inside the neuron to produce a strengthened synapse. Now, when I say a strengthened synapse, what does that mean? Well, basically, the strengthened synapse means the same thing it always means. And that is, it means you're going to create more AMPA receptors. Yeah, you're going to create more AMPA. It's basically always the case. AMPA is the workhorse. That's the army that comes in that you've got a powerful synapse when you see a lot of AMPA. Having NMDA, all that means, if you think about it, is that the synapse is not necessarily strong, but it's got the potential to become strong, right? That's what NMDA really means. And in the striatum, you also need dopamine in order to strengthen it, because you're only going to strengthen the synapses where glutamate was coming in, that is where you had that circuit going, as you got this reward. And then it's kind of logical. Whatever I was doing when I got the reward, I want to do more of it. So you strengthen that synapse, all right? And sure enough, you're going to end up with more AMPA receptors here. You're not going to end up with more in this, what I called synapse 1 in this case. And the reason, again, is, if you just focus on the synapse, you could say, just ignore what's going on in what we'll call synapse 2. If you just focus in on synapse 1, you say, well, synapse 1 does have dopamine binding, doesn't it? Well, that's because, when you had some positive experience, dopamine surges, and it's like a flood. Everything gets wet, all right? So you've got dopamine binding to all these receptors. So what that shows you is that dopamine is necessary in order to get a strengthening of the synapse, but dopamine by itself is not enough, is it? Because if dopamine was enough to strengthen a synapse, then this synapse number one should have gotten strengthened. Well, we're glad that it didn't, because it would make no sense. So I'm watching this video, I'm enjoying the heck out of it. Dopamine's like flooding my synapse. Well, I should strengthen my likelihood of repeating the watching the video. It would make no sense that you say, yeah, I watched the video, I really liked it. Oh yeah, and you know what? As a result, the next day I couldn't wait to make lasagna. What? If you're doing A and you get a dopamine reward surge, it makes no sense for that to strengthen your desire in the future to do something else. It should strengthen your desire to do that same behavior. So yeah, so the next day we don't get an increase in AMPA here. This was already there. We get an increase in AMPA there. And here's kind of the thing that's I think worth kind of noticing, guys. The next day, you can look at my brain and say, oh, you know, you never know for sure whether John's going to choose to watch a video or cook lasagna or do something else. I mean, there's going to be some randomness in terms of what actually gets chosen. But you could basically say, based upon looking at the AMPA receptors, you can tell what you've got the best likelihood of choosing. Because there's kind of noise going on here. Chemicals bouncing around, neurons been a little more hyperpolarized or depolarized just randomly. But if you have more AMPA receptors, all in all, you're going to be more likely to activate that neuron. So you could say the next day I'm more likely to watch video. And what's really interesting to notice is, as I'm deciding what to do, I don't really need a surge of dopamine, even when I think about watching the video. Maybe it's nice. Maybe I think of the video and the thought of it brings up dopamine. That's fine. But you can see that the effect of the reward yesterday watching the video is enough to make me more likely to watch the video today, even without any dopamine, even before there's any dopamine. Because if I activate these neurons, you know, and think about watching the video and release glutamate, it's already got more AMPA receptors. And now I activate this, I start watching the video, and if it's still even better than I remembered, I'm laughing just as much as I did the first time, you know, you get more dopamine coming in while that glutamate's binding to these receptors. The next day I'll have even more AMPA receptors. Now, by the way, let's suppose I've watched this enough time that I can tell where all the funny lines in this video occur, or the funny scenes. And so, like, I watch it the next day, and it's fine. You know, it's good. I enjoy it. But there's no surprise reward. It's like my brain basically knows how good this thing is. I don't get a surge of dopamine, right? Well, what would happen there is I would just have basic levels of dopamine, you know, no big surge. But I've already got that increase in AMPA. Now, if I do the behavior and I'm disappointed that it's not as good as I expected, and I actually get a drop in dopamine, I'm not really showing you that you've got kind of a background level of dopamine, it can go up or down. If dopamine actually went down, I could lose the AMPA receptors. All right, so Michelle says, what happens if you do an action so many times that, yeah, you start getting tired of it? I think it does mean that you would get less AMPA receptors, Michelle. That would be a situation where if you're getting tired of it, see, I guess we could talk about three situations. One is you're pleasantly surprised by how darn good this was. Number two is it's like just reliably good as you thought it would be. And the third is it's not as good as you thought it would be. I don't know if anybody's ever watched a show that you watched like years ago and you thought was great, but like through your eyes now, say 10 years later, it's like, well, I guess maybe it's not so charming as I thought, you know? Well, what would happen there is it's just sort of like with juice, right? You could get the amount of juice that you expected. You could get more juice than you expected, or you can get less grape juice than you expected. If you get more, you get a surge of dopamine. If you get the amount of juice that you expected, the dopamine stays kind of at its baseline level. And if you get less than you expected, dopamine actually drops lower. In order to lose AMPA receptors, what you need is dopamine to drop lower. And actually, what you need is to be doing the behavior while the dopamine drops lower. So if you think about it, if I'm watching a video and glutamate's binding to its receptors and dopamine drops real low, that would be a recipe for reducing AMPA. I'm not going to ask you to sort of be able to sort of come up with that on the fly. I think it's enough for us just to think about the fact that what you need is glutamate binding to this, at the synapse while the dopamine arrives, and then eventually within hours or a day, you get more AMPA receptors. But the answer to Michelle's question is yes. If you're disappointed by the thing you're doing, AMPA receptors would go down, and as a result, you'd be less likely to choose it tomorrow. And that is to say, when you think about it, probably you wouldn't feel such motivational drive. Yeah, and like Jade said, you'd lose AMPA receptors. That's right.